Hi. Today we are going to see some important formulas from chapter Structure of Atoms for class level chemistry. This session will definitely help you to do the questions from this chapter easily in JEE, Neet or class 11 chemistry. Let's see what these are. Relationship between velocity, wavelength, frequency and wave number of a wave. Let's see what are the important formulas connecting them. First of all, you know, C is equal to nu lambda, right? C is equal to nu lambda. So, nu is equal to C by lambda. So, C is the velocity of light, nu is the frequency and lambda is the wavelength. So, that's the relationship between these three. And we can get nu is equal to C by lambda. Now, you know nu bar, which is the wave number, that is the reciprocal of wavelength. Nu bar is equal to 1 by lambda. Now we can connect them again. How? You know nu is equal to C by lambda. That means it is C into 1 by lambda. That means it is C into nu bar. So we get a new relationship, that is nu is equal to C into nu bar, or nu bar is equal to nu by C. All these formulas are very, very useful. Now, the next one. Energy of a photon or quantum. Let's see what is the energy of a photon. Energy of a photon, you know, photons, they are the particles of light, right? Quantum is the general term. Photon is applicable for light. So, E is equal to h nu. That is, h is the Planck's constant and nu is the frequency. So we can say E is equal to h nu. Energy of a photon is E is equal to h nu, or h into nu is C by lambda. So we can get E is equal to h into C by lambda. So when you use this, C is the velocity of light, 3 into 10 raised to 8 meter per second, and lambda should be used in meters. You have to take care of that. Now, the next one. Kinetic energy of a photoelectron. That is, photoelectrons are ejected from the metal surface when light of appropriate frequency falls on the metal surface. So what is the kinetic energy of such photoelectrons ejected? What is the formula? Here the formula is kinetic energy of the photoelectron ejected is h nu minus h nu 0. Here this h nu is energy of the incident light. That is h into C by lambda, energy of the incident light. And what is h nu 0? That is known as work function of the metal. So, kinetic energy, which is half mv square, is equal to h nu minus h nu 0. This is energy of the incident light. This is the work function of the metal. Now, the next one. It is about Bohr model of atom. Then from that, we have certain formulas from Bohr atom model. So let us see what are the Bohr atom model formulas. First one, energy of different stationary states. Suppose energy of a stationary state is taken as En. That is energy of the nth state. So the formula will be minus 2.18 into 10 raised to minus 18 into 1 by n square. Minus 2.18 into 10 raised to minus 18 into 1 by n square. This is for hydrogen atom. And here it is joule per atom. That's a unit. Now, suppose you are not dealing with hydrogen. You are dealing with a multi-electronic system. Hydrogen is a single electronic system. This is applicable for any single electron system. Suppose you are dealing with a multi-electronic system. Then how can you modify this formula? En is minus 2.18 into 10 raised to minus 18 into z square by n square. You know, n is the orbit number, energy, that is the stationary state number, orbit number, and z is the atomic number of the atom involved. Clear? Now, this is joules per atom. We can also express it in joules per mole or kilojoules per mole. This is for one atom. What is the meaning of 1 mole? It is Avogadro number of atoms. So if you have to convert this into mole, you have to multiply this by Avogadro number. Then what will you get? we can write it as, so then En will be minus 2.18 into 10 raised to minus 18. This is for one atom, into 6.022 into 10 raised to 23. Now it will become joules per mole. Then you'll be getting minus 1.312 into 10 raised to 6. That is this into then 1 by n square for the formula. So minus 2.18 into 10 raised to minus 18 into, you multiplied it by Avogadro number, into 1 by n square. So this is 1.312 minus 1.312 into 10 raised to 6 into 1 by n square. This is joules per mole. And if you want to convert it for multi-electronic systems, you have to just multiply it by Z square. Okay. So minus 1.312 into 10 raised to 6 into Z square by n square joules per mole. Clear? And if you want to convert to kilojoules, divided by 1000, so it will become minus 1312 into 1 by n square or Z square by n square. It will be kilojoules per mole. Hope that's also clear. Right. Now, the next one. What is the radius of the nth orbit or radius of the nth stationary state? Then the formula is radius of n orbit. If it is hydrogen atom, it will be a square. Sorry. Now let's see what is the radius of the nth orbit. Radius of first orbit, second orbit, third orbit, etc. If it is hydrogen atom, what is the formula? Radius of the nth orbit is equal to n square into a0. This n is the orbit number. If it is first orbit, n is 1, second orbit, n is 2, and so on, into a0. This a0 is 52.9 picometer. So if you use this formula, you will be getting the answer in picometer. And if it is not hydrogen atom, if it is a multi-electronic system, then Rn will be n square by Z into a0, 52.9 picometer. Where, as usual, Z is the atomic number of the atom involved. Clear? So these are the formulas connected to radius of nth orbit. And picometer, you can convert in nanometer, Armstrong unit, etc. as per the questions demand. Try to practice these formulas and do questions connected to this. Okay? Good luck.